Hello, everyone. Thank you for joining and welcome to our Sonar webinar entitled Clean Code Principles and Practices, Part 2, Mastering Clean Code. I'm Liz Ryan, your moderator for this webinar, which will be presented by Peter McKee. Please allow me to quickly go over some essential housekeeping points before we get started. This is a 30-minute session with a 10-minute Q&A afterward. Please use the Zoom Q&A box to ask questions, not the chat box. And we have two panelists joining us today, Ann Campbell and Manish Kapoor from our community and product marketing teams. They're tasked with answering as many of your questions as possible live during the webinar. This session will be recorded and we'll send out a link via email in the coming days. Finally, at the end of this webinar, a short survey will appear on your screen. We welcome your feedback. Thank you in advance for your participation. So without further ado, I'd like to introduce today's presenter, Peter McKee. Peter is the head of developer relations and community at Sonar and maintainer of the open source project Ronin.js. Originally from Pittsburgh, Pennsylvania, but currently residing in Austin, Texas, Peter built his career developing full stack applications for over 25 years. He's held multiple roles, but enjoys teaching and mentoring the most. Peter, I'll send it over to you.
Awesome. Thanks, Liz. I thought you were going to say 45 years for a minute. I would have taken that.
Should have.
Yeah. All right. Thanks. Hello, everybody. Thanks for joining. I really appreciate it. So yeah, today we're going to be we're going to do a quick review of clean code. I'm going to go a little bit deeper this round. If you were with us a couple months ago, I went over clean code, but I didn't go much into the details. I'm going to talk a little bit about our thinking around clean code. And then we're going to take a look at achieving clean code with our methodology called Clean as You Code. And then we'll take a look at setting up Sonar with a demo. All right, so let's jump right into it. So what is clean code? So there's a lot of books out there in the industry, a lot of good books. There's a couple of them. There's a lot of good websites. And we talk about what clean code is, what good code quality is. I like to equate it to a famous U.S. Supreme Court judge said once when asked about obscenities. He said, I'm not sure I can describe it to you, but I know it when I see it. And that's kind of how we think about clean code a lot of times is, when I look at a piece of code, how do I know it's written well? How do I know it's maintainable? Those type of things, right? And here at Sonar, we're really bullish on code, right? We think that everything starts with the code. And so we really took a deep look at how do you understand clean code? How do we categorize it? How do we talk about it? And then how do we produce it? And so we started looking at security, maintainability, reliability, and that rolled into bugs and code smells and those type of things. But we ran into a little bit of a problem. Down at the bottom there, you can see the patterns in code that lead to bugs and code smells and so forth. Well, down to the right, you can see that those pattern in code doesn't always just apply to one bucket, right? So you could have a pattern in code that looks like a bug and is a bug, and also could be a vulnerability. And so when we started looking at these things, we started to identify software quality, so security, maintainability, reliability, and others. And then clean code attributes, patterns in code that kind of make up things. And they were kind of distinct, but also had these patterns that matched into qualities. And so we started moving and shifting things and looking at categories and attributes. And you can see that attributes produce an outcome. And underneath our attributes, you have different categories. So you have a category, subcategory, and then you have a pattern in code. And these categories could, you'll see that we're highlighting the security quality on the right, and then the two green categories, and those flow down. And as we move along here, you can see that maintainability, security, all don't sit in just one category. They come across. And so as we look at reliability, the first category on the left, it goes down to blue. And if you remember up here at security, it was hitting the same bucket. So these things have crossover. They're multi-hierarchical. And so how do we know when your code is clean? How do we know when you have maintainability, reliability, and so forth? And these are the attributes that we came up with, and we've kind of took a look at these pretty hard, pretty deeply. And so you have consistent, intentional, adaptable, and responsible. I remember these as CIAR. You can remember it however you want. But underneath consistent, we have formatted, conventional, identifiable. Intentional, we have clear, logical, complete, and efficient. Adaptable, we have focused, distinct, modular, and tested. And responsible, lawful, trustworthy, and respectful. And let's talk a little bit about these. I'm going to give you some details around some of these, but you can see these attributes lead into qualities: maintainability, reliability, and security. So let's take a look at these clean code attributes. So clean code is consistent, and part of consistency is well-formatted code. This is a pretty simple example, but it illustrates the point very well. So we have some Java code here. So if you look at a non-compliant code, it's a little bit easy to see because you have the red blocks there and the green blocks on the below. And it's indicating that you have your tabbing, your formatting off, right? And on the surface, you might say, well, not a big deal. We're going to argue about it. Should we have 2 tabs, 4 tabs, spaces, whatnot? At Sonar, we don't care what kind of whether you use tabs or spaces. We don't have an opinion on that. We do have a strong opinion on it should be consistent, and it should be consistent across your code bases. It makes it easy to read, easy to flow. What we do as software engineers is we take real world issues, business flows, those type of things, and we put those into abstract code, right? We represent them in abstract code. And therefore, we have a lot of cognitive overload. We put all of these software classes and patterns into our head, and we try and manipulate them. And our brains are a pattern matching engine, right? And so when they read down the code, they need to see consistency. It makes patterns easy to view and to read, and it lowers your cognitive overload. And so another part of being consistent is conventional. So this is a C++ example. So code should be idiomatic and follow syntax conventions. I'm not a C++ developer, but apparently in version 11 or above, there's a couple different ways you can do type analysis, aliases, but pardon me, with the type def and the using. The using structure is the more modern way of writing C++ code. So if you're using the more modern way, you want to stick to that convention. You want to use that across your code base, again, for consistency and the ability to easily reason about your code. Let's move on to intentional. So intentional, again, a pretty easy one to at least have in your brain, but when you see it in code, it becomes a little more confusing. So code should be clear and straightforward. So if you look at a non-compliant code, I believe this is some Ruby code, Ruby or Python. But as we read down through the top, so we have hello, it takes a parameter called name. Then it's creating a variable, assigning hello, concatenating name to it, and then we print name, right? Right away, we start to get confused. Why do we have message declared, or we're not using it? Should we be using it? Is that a mistake? Am I missing something? What is going on, right? So even in just a simple, what is that, 5 lines of code, we start to get confused. It's not super clear. And then the variable I, right? We never use I. We're just looping through 10 times and printing and calling foo. Not exactly sure what's going on. So below that, right, you can see that we have hello, and then we create a variable message. We concatenate and assign to message. And there we go. We use message. And then we use the underscore kind of throwaway variable to indicate that we're not really going to use that. So it's a lot clearer, even if it is only 5 lines of code. I hope you can see the point of being very clear in your code. Another part of intentional is being efficient. So this is a Docker example. So code should be efficient and not waste resources unnecessarily or needlessly, let's say. So in a non-compliant code, so a Docker file is basically a shell script. It's going to run commands. Those commands are going to produce an image that then later you can run. So when you do run apt-get update and then an apt-get install nginx, apt-get is going to install things, and you're going to get that you might not want, and it's going to bloat your image. So you can see down in the compliant code, we have an extra line in there that says apt-get, and it's doing a clean at the end, which should clean up unneeded resources. In this example here, just a little nitpick for me, I like to move the double ands to the end so you kind of line up all your apt-gets. But again, doesn't really matter. If you put them all in the same place, it's also consistent. Another quality is adaptable, and part of that is being distinct. Code should be distinct and minimize duplication. Again, here's a pretty rudimentary example, but it proves the point. So in the non-compliant, you see a string with action random 1. that string is being repeated. Typically, we wouldn't see it something like this, 3 lines right in a row. You'll have extra code in between the prepare and execute and release. And so therefore it gets spread out and you can't identify those strings everywhere. An issue immediately recognizable is how do I maintain this, right? And it's not adaptable. If I go to change action random 1, I got to change it everywhere I use it, right? Classic example. So you can see the compliant code. We declare a variable action 1 and we set the string to that. And then we use that variable everywhere that we need it. So you only have to change it one place. 2, in this larger code base, that action 1 would probably mean something, right? And so then when you see action 1 throughout your code, you know exactly what that is. Another piece of adaptability is being modular. So code should be modular, and as a key aspect of this is encapsulation. So we have a VB.NET example over here to the right. In the non-compliant, you see we're using a public property, a public variable. And sure, when you're starting out, that might be okay. People will start using this code, and they're going to use that bar. They're going to access it directly. So it's not going to make it very modular, right? It's going to tightly bound it to your other code, right? The base of adaptability is being highly cohesive and low coupling, right? So you don't want your code to be bound together, right? And so part of being modular is to break those pieces apart and give good interfaces. So in the compliant code, you can see we're doing a class and we give a public property, right? Properties are better because they'll have getters and setters. If you need to change the functionality of how you set the value bar with some logic, you can do that in your setter function. Okay. So moving on to responsible. First one is trustworthy. So code should avoid hard coding secrets, right? Pretty easy example to illustrate what we're talking about here. So in the non-compliant code, you see a function, and we've hard-coded the user and the password, right? That's a big no-no. To fix that, move it down into functions that go read that data off a secure input. However you want to do that in your programming environment, you should use those constructs and not hard-coded in there. Okay. And the last one we're going to take a look at is lawful. So code should be lawful. It should respect basic licensing and copyright regulation. It exercises the creator's rights and honors the rights of the license and their owner. So we have a lot of our code is open source and free. We have our open source license. We put it in all the top of our files. We ask that you respect that and others respect ours. We respect other people's licenses. So, basically don't go steal other people's code, copy it, reuse it, attribute it back to the original creator. And there's some other attributes in responsible around lawful too, but let's move on. Okay, so we talked about clean code, what it is, how we look at it, how we identify clean code. What are the categories? What are the patterns in code that we're looking for, right? So we went from a pretty high level theoretical understanding of clean code down to more of a tactical, how do you actually produce clean code? And so at this point, you might say, well, how do I get to clean all of my code? And we have a methodology here at Sonar called Clean As You Code. And that uses the power of static analysis. So with Sonar, the Sonar Analyzer, we have over 5,000 rules. English is hard today for me. So 5,000 rules, 30 plus languages. We scan all of your code, run all of your code. We use quality profiles. I'm going to show you that in a minute. And we look at it all kinds of different issues. Some of my favorites are cognitive complexity, crypto functions, secret detection, which we saw earlier. So we look a lot at your code and we handle a lot of issues. But what happens, right? You turn on a static analyzer, any kind of scanner, and you get thousands of issues, right? And as a good engineer, you turn that off, right? And you go about your business. No, don't do that. So again, use a methodology called Clean As You Code. So Clean As You Code, you focus only on the new code. So only added or modified code. And what this does, it allows you to get the work done as you're working on features, as your coding is fresh. It's non-disruptive, and it allows developers to do their best work. As they're coding, as they're working, they're cleaning their code, either added brand new code or modified code, right? And as you're implementing, it takes two steps. You're going to set up a quality profile, which defines the standards. It's a set of rules that we're going to apply to a piece of code, to our code base. And then your quality gate is a scorecard on how good that code is and whether it should pass on in the CI/CD pipeline, or you should stop it, right? And it takes it takes a look at things such as security, vulnerabilities, bugs, those type of things. And we're going to see that in a second. And so you set up, you only take a look at modified or new code. You set up your quality profile, you include a quality gate, and then only when that quality gate is green is when you merge. And so what happens? So you might say, well, I'm only cleaning code as I go, and that's going to take forever, right? I'm not always touching all of my code base. And you're right. And so what we did, we kind of looked at, we have a tool, that open source tool called Get a Thesis. We applied it to some major open source tools, projects out there. And we found that after about 5 years, you get down to a little bit less than 40%. And it depends on your specific project. But looking over this, this broad range of projects on GitHub, after the first year, you get down to around 80%. So you cleaned roughly 20% of your code. After 3 years, you've cleaned about 65, 70% of your code. And then about 5 years, you can see in the graph, you're starting to dip below the 40%. So you're cleaning over 60% of your code. I do get a question a lot to say, well, after, what about that 40% of the code that I haven't touched? Don't worry about it. Is it maintainable? Maybe not, right? But it's reliable, it's secure, it's running. If it wasn't reliable and secure, you would have been in there, you would have been working on that code and fixed it anyways. The real issue is around maintainability, but if you haven't touched it in 5 years, you might not ever touch it. Okay, so let's take a look at a demo here. Okay. So first thing I do is I'm going to go into Sonar Cloud and I'm going to log out. I'm going to show you how you can set things up. So when you first go to Sonar Cloud, you'll see Explore Projects. I want to highlight something here real quick, which is really, really cool. So we scan a lot of open source projects and we put the results out here on the public. So if we take a look at Amazon's AWS Java SDK, you can see right now that it's failing a quality gate. You can actually go into the pull requests. You can take a look at a failed pull request and you can see the issues that are happening. 412 code smells. So if you want to help out, you can go clean some of these up, but it's pretty cool. You can take a look at open source projects. Go take a look at some of the open source packages that you're using and see what kind of vulnerabilities are in there. Okay, so we're here at Sonar. We've got a new project. So let's set this up. So I'm going to go and log in. When you log in, you can obviously log in with GitHub, Bitbucket, GitLab, Azure. I'm going to log in with GitHub. I'm already logged in. I've already authorized through GitHub, but if you haven't, you'll be presented with to authorize into GitHub and authorize Sonar to access it. Once you do that, then you'll come back into Sonar, come up here and say, I want to create a new organization. This will go out to your source code repository, take a look, see what organizations you have. I'm going to import the Strata organization. So you give it some details, a name and a key. This little hint here will tell you that all the members in the GitHub organization will be added into the Sonar Cloud organization. And then you choose your plan. So I'm going to do the free plan. We'll move over. And then here at this time, you're set up, but you don't have a project. So you would go in, choose a project. Again, here's my organization. I would choose Strata, and then I would hit setup. I'm not going to do that now because it's going to run a scan. So let me jump back into our projects. And I have a small application that's been written before called Clean Code Alpha. You can see my quality gate is passing right now. Everything seems to be working fine, right? Well, I have I'm sitting on a sprint. I pulled off a ticket off the backlog. I have to change. There's an issue with our database sessions. And so I'm going to fix that, right? I've already fixed the code. I've written the code and I've pushed that up into a PR. And so when you do that, Sonar will pick up that you've created a PR and it'll scan it. And you can see here, this fixed DB sessions is that PR, and I failed, right? So my quality gate has failed. I have issues that I need to go and fix first, right? The main one we can see here is this security vulnerability. But I also have a maintainability, one code smell. So let's click on that. It's an intentionality issue, right? And you can learn about more in our documentation about that. And so here I'm going to click on the actual issue, and it's going to take me into my code. If I scroll down a bit, I can see, oh, okay, well, I didn't add a let or const or var at the beginning of this. Not sure why I did that. But if you are curious of why this is an issue, you can click on why this is an issue. You can read down, learn all about var, let, and const, and why you should use each, right? Activity is where you can go in and add comments. I love this rule, all right? And so here's where you can have a thread. You can discuss this actual rule with your colleagues, whether you want to change the status of it, remove it, and those type of things. And then when you click into more info, this gives you more info where you can learn all about this issue and why you should fix it. Okay, cool. So let's jump back to the summary. Let's take a look at our security vulnerability, which is really what is causing us to fail, right? As you can see, we have an A rating here. We have an A rating, maintainability, security. Our duplications don't look bad. And so let's go and take a look at our vulnerability. It's a responsibility issue. And I'm hard coding some passwords, right? That's not good. We should never do that. This is actually probably been reverted from an earlier version of this feature. And as I fix the sessions, I inadvertently overwrote this. Shame on me, poor merging of branches. Okay, so I want to come over here and show you, after that PR is run, this is scanned, we've gotten our results. Back here in GitHub, you'll see on my PR, so in my pull requests, come over, and this is a fixed DB sessions. And you can see it's decorated my, my pull request. It's showing me that I have a vulnerability, code smell. So as an engineer, you don't even have to leave this IDE, right? You're inside the IDE, pardon me, not in the IDE, you're in GitHub, you're in your pull request, you see the issue right here. And as we scroll down, you can actually see the code snippet that's saying, hey, here's the issue right here. So you can go and fix that in your code base. So let's take a look at the code right now. And before I do that, so I'm looking at the code, here's the issue right here. I have a hard-coded password here, and which is a big no-no, of course. So, but before I fix it, I'm going to show you, we have Sonar Lint, which is a linter that you can use in your IDE to see the issues and clean them locally, so you don't have to cut PRs, see your issues, come back in the IDE, go back, okay, what file is that in? Is it over here, right? Searching all around. So if you just come into the extensions, and this works across all your major IDEs, just use the normal flow of installing extensions. So here's Sonar Lint, click on that, and I'm going to click install. So that's been installed. Let's come back to our source code. Let's close this down. You can see I don't have any problems detected yet, but as I open my files, you'll start to see the issues should come up. Let's go. Oh, there they go. Thank you. So there's one. Let's open my server. And now we can see the two issues, right? Right here. It tells me add, let, get, and so forth. And you can see it's Sonar Lint, JavaScript, and this is our rule number, S2703. So right here in the IDE, we can see our issues. We can jump to them. We can fix them, right? Okay. So for the sake of time, I fixed these issues. I've created a PR, and I've pushed that up into GitHub. And another analysis is kicked off. So if we come over here into our pull requests, you can see fixed DB issues, double zeros, and you can see the scan ran and have passed, right? I don't have the security issue has been fixed and the maintainability issue has been fixed. And again, on the PR, if we come over, our PR has been decorated. We can see we have 0 issues, and our merge pull requests button is nice and bright and green, so we can go ahead and merge. Okay, one more thing I want to show you before we jump out of here is, let me go in to our organization, and I want to take a look at the quality profiles and quality gates. So a quality profile, like I said before, is a set of rules that you want to apply to a project. And you can read about a lot of this on the page and in our documentation. I'm not going to go too deep. I don't want to do a product, training session, but I want to give you a hint of what it looks like. So, of course, there's a list of all the languages we support. Most of them have this profile called Sonar Way. That's our default profile for all of our languages. And so let me go into the language we're using here, which is JavaScript. So we have one profile called Sonar Way. If we click on that, we can see the inheritance tree right now. This is at the root. And then over here, you can see we have a 265 total rules, how they break down. You can see we have inactive rules, right? And you could click on those, and then you can navigate and see what issues are included in that. Also, too, if you wanted to change these rules or you wanted to create your own profile, the best way to do it is you want to go and you either want to copy or extend. The difference between a copying and extending is if you're a software engineer and you've worked in object-oriented programming, it's the same thing, right? So if you copy a profile, you'll take the properties and rules and you make a copy of them, and then you can extend them from there. You would want to do that if you copy it. If you wanted to control that base profile. When Sonar is updated, we update our profiles, not always, but sometimes we do. We'll add rules, but we'll move rules. If you don't want that, then you want to copy and then you're going to extend. If you want to keep the base Sonar Way, so you get those new rules as they're updated, but you want to modify it, you extend it. So you'll extend it, you can make modifications, you can activate a rule, deactivate a rule, and then when Sonar comes in, you'll get the new rules and they're still hierarchical. So that's the way you want to look at that. Okay, excellent. So let's jump back over. And Liz, kick it back for you. But while she's coming back online, if you want to get started, you can get started for free. We're going to drop the links in the chat. We'll get the team will take care of that. If you don't get a link, you don't have a question, please reach out to me on Twitter, LinkedIn. I love to talk to people. If you're using the products, give them a try. If you have any issues whatsoever, jump into our community. We have some great technical community managers in there. They're going to get you your questions answered and get you pointed in the right direction. A lot of our engineers in there, and they will help you troubleshoot and get things fixed. All right, time for me to be quiet. Over to you, Liz.
Awesome. Thanks, Peter. That was great. As we move into our time of Q&A and I gather the questions up, I briefly wanted to share our 2 upcoming webinars that you can attend. We've got Clean Code, How Mistakes Can Make You Great for APAC and EMEA on Tuesday, September 26th. And we also have Clean Code in Java, a story of monsters, heroes, and victories from our developer advocate for Java, Jonathan Villalopez. That's October 18th. So let's look over and see what questions we have for you, Peter.
All right.
All right. We've got one from Joey who asks, would the Git PR decoration be the same between Sonar Cloud and CenterCube?
Oh, that's a great question. Yes, I believe so. The same information is there. It might look a little bit different, but yes, the same information is there on the decorations.
Okay, great. We have another question. When working with an existing code base, would CenterCube analyze the entire file or just the updated lines?
So it analyzes the whole project, but only looks at the new files, new lines of code that you've changed, right? So yes, it still looks at the whole file because the way we do our analysis is comprehensive. But yes, it's only worried about the new code that you've changed, right? Yeah. So the answer more succinctly, it scans everything, but only tells you the issues with the codes that you've changed or added.
Perfect. Okay, we've got a couple more here. With Clean as You Code as an organization where only new and modified code is analyzed, an issue we come across is when a line of code is modified, it impacts our code coverage metric. Is there a way to break out new versus modified?
Oh, great question. I do not believe so, but to be honest with you, I'm not 100% sure on that answer. Let me get that answered for you, and we can drop it we'll answer it in the community. Yeah, I believe it is no, but you can set it because there's only really 2 ways to set it up, if I'm correct. It's by a date, number of days, or new or modified. So those are kind of your 2 options. But let me I know we're making changes and stuff, so let me dig into that. And we'll get it answered on the forum, in the community forum. Great question. Thank you.
Absolutely. We still have time for a few more, so I'm going to keep coming at you, Peter.
Right on.
How do we as a team improve our code reviews using the principles of clean code?
Oh, great. That's a great question. Um, so code reviews are interesting. They're necessary in my mind, right? But sometimes they're set up to be adversarial, right? You, our career has to relies on a lot of our ability to reason and to be smart and to know a lot of things, right? And so when you do code reviews, sometimes it's an opportunity for such junior folks to show how much they know by beating up other people's code, or sometimes more senior folks. They're not always the most gentle folks, and they're beating up more junior code or their peers, right? And you get in a battle around should you use concatenation, should you use the dot concat function, these type of things, right? And with Sonar, our static analysis, right, it eliminates a lot of those discussions, a lot of those arguments, right? Sometimes it'll lead into arguing about the rule, but I think that's a better place to argue, right? That's a more data-based argument around the rules instead of their application across the project. And so I think the way you improve them, right, is to use static analysis. That'll help eliminate a lot of the people that come in with cognitive biases and those type of things. That'll help eliminate a lot of that. And then you can focus on the structure and functionality of the code, and you can really look at the deeper things that we don't really handle. It's a little bit harder to handle architectural issues, things between cohesion and coupling, right? And so the team can focus on that and not so much on the tactical, simpler rules, right? And there's also rules that we have around security and those type of things, and taint analysis that are very, very hard to see as a human, right? You have to really dig through the code. It's not going to be super obvious when you're looking at just a single PR. It helps to look at how the code fits into the larger picture. So hopefully I answered that question, but I think if you're using static analysis, that'll help minimize and streamline a lot of your code reviews. And if you focus on architectural issues and code construction issues, then that will should help improve it and make it more enjoyable for everybody.
Okay, great. How do you change a quality profile but make sure you are up to date with all the new rules that Sonar releases?
Yeah, I think it's a good question. Jumping back, we have a couple different best practices, but you want to do that with extending, right? Remember, you can copy and extend. If you copy a profile, then you kind of break that connection back into the original Sonar way. And so when we update Sonar way, you won't get those changes. That's copy. So I recommend extend. So extend the Sonar way, add and remove rules that you need. And then when Sonar way is updated, you'll get those rules updated for you also. And then only a copy when you get to a point where you feel really, really comfortable when you know what you're doing, right? You know how to handle that. You want to handle it all yourself. And that's totally fine. I didn't show it. There's also a compare feature. So if you are copying it and we update some rules, you can do a compare. You can see what has changed. And also at any time, if you do copy, you can compare and that gives you an idea of what you changed in case it's not super obvious sometimes. But yeah, I would use extend, and that will keep the rules that are coming out from Sonar Way. They'll still update, and your extended profile will still have those.
Okay, we've got a SonarCube specific question now. Can SonarCube detect bad architecture issues?
Ooh, not 100% sure what you mean by bad architecture issues. Oh, in code architecture, I think they might be talking about.
Let's go with that.
Yeah. Okay. Cool. No, it can't. And I was actually talking to some folks on the engineering team, and I was asking them to do that. Right. That would be the next level. It'd be really cool, right? Where do you how do we scan and understand your architecture, and how do we give recommendations? It's really hard to do. Again, I talk a lot about cohesion and coupling, right? Your boundaries between your pieces of software are abstract, and so finding those are very difficult, and setting those are very difficult, right? As software engineers, as programmers, as designers and architects, um, defining where your domains are within your software is very, very hard. And so doing that as an analysis is interesting, right? I'm not saying it can't be done, but I think it's something we're thinking about. But right now, no, we don't do that. If I understand your question, no, we do not do that right now.
Mm-hmm. Okay, and then this one is actually administrative. Peter, if you can go back to our webinars slide, Keith requested just to see the details of our next two webinars real quick.
Yeah, right there.
And we'll also be sending out these details via email, and they'll be available on our website. So How Mistakes Can Make You Great is coming September 26th for APAC and EMEA. And then we've got Clean Code in Java, a story of monsters, heroes, and victories. That title is very enticing, in my opinion. Wednesday, October 18th. Yeah. So those are our two upcoming webinars. I have a couple more questions. I know we're running out of time here, so I'll just hit you with a couple more.
Okay.
Is there a version of Sonar that we can download and try today?
Yes, you can get our community edition. So you can go up to our website. We'll drop the link in there, but yeah, download our community edition. You can run it locally. We also have Docker images. If you know Docker, that's probably the easiest way to do it. 2 images, go grab those, the UI and the scanner. I used to work at Docker, but I made the mistake when you run them, make sure they're on the same network so they can talk to each other. Pulled my hair out for a couple hours and then realized, yeah. Anyways, yeah, that's probably the easiest way. It's called a community edition.
Perfect. We had one last question coming in here. Oh, okay. Sorry.
I was just to jump in. The question was around download too. I get that, but you can also get a free tier in cloud. So you can go and mess around with cloud on the free tier if you want to get more advanced and download Cube. Okay, sorry, Liz.
No, that's great. We have one here. How often does Sonar update the default quality profile with new rules?
It's not a set time. I know when we do our dot releases, you potentially could have rules in there. We don't have a set cadence as far as I know. So, but it's not random. So when we get enough rules set together, then we'll release them. It's done programmatically, but not on a cadence. So, keep an eye out for our, stay connected on our social and look at the READMEs.
I was going to say, and community is a great place to go too if you want more information on our announcements related to our new rules. So
yes.
Okay, well, we only have a couple minutes left. I think we've covered most of the questions here. Any questions that we haven't covered, we will certainly follow up and get them answered. And Peter, thank you for answering all those questions. Thank you all who stayed on the line and posed those questions, and we'll make sure that we get them all addressed in the future. We hope that you'll visit sonarsource.com to come see more clean code content and learn how to clean as you code, and check out information for our future webinars and events, as you can see here on the screen. Thank you again in advance for providing your feedback via the survey that will appear shortly on your screen. So thanks everybody, and we'll see you all soon.
Thanks everybody.